This is on page 57. So page 57. A particle moves a vertical coordinate axis so that its position at any time bigger than 0 is given by function that, where s is measured in centimeters and t is measured in seconds. So here's what we have. A particle, here's my particle, it can only move up or down. Makes sense, okay? Now, s of t represents our position. So it tells you where you are. Now let's go look at displacement. So part A, find the displacement during first 6 seconds. Okay, that means where are you? So let's see where we are. I really don't even like this wording. I really want you to just find where you are at 6 seconds. That's what I mean. I just want to find the displacement at 6 seconds. Let's go and fix to that. Okay. In order for me to figure out where I am, not where I'm going, is I'm going to be looking at my position. I am position at 6. So I'll go ahead and plug this in into every piece. And that is going to give me where I am at 6 seconds. Good? I'm not going to evaluate this, but this is going to tell me where it is. But my unit would be centimeters. Part B, average velocity. So this is a rock. Okay? Whenever I do average rate of change, I need to get to velocity, which means it's the average velocity is the answer that I want, which means I took the slope. So average velocity is slope of position. I'm going to go ahead and write those there so we can compare. So I got to take the slope of position during first 6 seconds, which means starting at 0 to 6 seconds. So this is my x1, or x2, really t1 and t2. Since it's average, we're not doing calculus, we're doing algebra 1. So we do s of 6, so y2 minus y1 over x2 minus x1. If you want to evaluate that, we can, but as of right now, that's all I want. And once you evaluate this, my unit would be, since we're in velocity, it's going to be centimeters per second, because they told us up here it was centimeters and second. Good? All right, the next 2 questions were these. Let's see if this will let me paste it. Okay. So find the expression for the velocity and acceleration. That's what they want us to do. So how do we get from position to velocity? We're going to have to take the derivative of that. So my velocity, which is derivative of the position, would be t squared, because I got to bring the 3 down. So 3 times third is 1. Okay, 1t squared minus 6t plus 8. My acceleration, which is derivative of velocity, would be 2t minus 6. Pretty good? Now, part D is asking you, for what values is part of moving downward? Moving means it has speed, so we got to look at velocity. Downward means velocity has to be negative. Now, if you were here during the summer, you remember this. If not, go ahead and pay attention here. I know this. I know it'll make sense to you. If I'm moving all over the places, I have speed, right? I have speed everywhere else. However, if I stop, do I have speed? No, that's my speed. That's when my speed is 0. So here's my theory. I'm thinking if I know where my velocity is 0, right? That means everywhere else is not 0, which means everywhere else I have velocity. So let's take a look at what I mean by that. So my velocity function, first of all, I'm going to write it down here. was t squared minus 6t plus 8. Now I'm going to see where this is stopped, and you'll see why I want to know when it's stopped here in a second, okay? In order for me to know when this is stopped, I gotta have to set it equals 0, because that's what it means. If I'm stopped, my velocity is 0. Now I'm going to factor this out because it's quadratics. This gives you t and t. So what times what gives us 8 and add to give us negative 6? I know 2 times 2 times 4 gives us 8. But they both need to be negative because it needs to multiply to give us 8 and add to give you negative 6 equals 0. And once we get here, we can set both of these equals 0. So t equals 2 and t equals, that's not t, well, t equals 4. Here's what I just found. I found this means at time equal 2 and at time equal 4, my velocity is 0. That means at time equal 2 seconds and at time equal 4 seconds, I'm not moving. Which means, other than 2 and 4 seconds, everywhere else in the function, I am moving. Right? That means I have speed everywhere else. So here's what I know. On my timeline, this is my timeline. This is my velocities timeline. Okay? At time equals 2, so starting at 0, right? This is where it starts at 0. At time equal 2, my velocity is 0. At time equal 4, my velocity is also 0. Which means in between 2 and 4, and in between 2 and 4, and in between 0 and 2, and after 4, it's not 0. It's something else. So we have to figure that out. Does that make sense? Okay. I hope so. Now here's what I'm going to do. I'm going to check what happens from 0 and 2 seconds by plugging in something in between 0 and 2. So I'm going to plug in time equals 1. Let's see what happens. At time equals 1, if I plug it into the velocity, or anywhere you want to, that's going to give me, I'm going to do my scratch work here so y'all can see. So t minus 2 and t minus 4 is my velocity. So if I plug in 1, I get negative 1, negative 3, which negative times is positive. So it gives me a positive velocity in between 0 and 2, which means I'm moving up. Okay, let's look at from 2 to 4. I'm going to pick 3. If I plug in 3, it's 3 minus 2 and 3 minus 4, which is my velocity function right here. If you want to, you can plug it up here, but these two are the same thing. So this gives us 1 and negative 1, which gives us negative number, which means I'm moving. I have a negative velocity, which means I'm moving downward. Likewise, I'm going to check right here. So I'm going to try to plug in 5. Then I get 5 minus 2 and 5 minus 4, which gives us a positive number, which means I'm moving upward. So I know that I'm moving downward from time equals 2 to 4. Now let's kind of recap what we did. I set the velocity equals 0 because that's going to tell me where I am stopped. As long as I know where I'm stopped, that means everywhere else I am moving. So here's what I found out. I found out that at 2 and 4, I am stopped and I am not moving. And that's the only time where I am stopped and where I am not moving. I'm moving everywhere else. So from 0 to 2, I just picked a point in between 0 to 2 and I plugged it in and it gave me a positive number, which means I'm moving positive direction, and in this case I'm moving up. From 2 to 4, I try to plug in 3 seconds, and at 3 seconds I was moving down, which means it gave me a negative velocity, which means I'm moving down. And from 4 to infinity, I picked another point, which is 5, and it gave me a positive number, which means I am moving up again. Good. And I hope this makes sense. So like, as long as I know where I am not moving, I know that everywhere else other than those points, it means I am moving.